Hi, in this video we're going to be looking at how we're going to write recurring decimals as a fraction. Now this is an example of a recurring decimal, 0.66666, and that goes on forever. And the shorthand version of writing this is 0.6 with a little dot on top. So this dot on top of the 6, it means that the 6 repeats itself. If we had 2 digits here, as I will show you in the next example, we would have a dot on top of each digit. Okay, let's see how we're going to do this. On the left hand side of this page, I'm going to do this sort of longhand so that things become much clearer, and then I'll do the shorthand on the right hand side, and then after that we'll just keep on with the shorthand. Now the way we do this, we will call this number, we will give it a variable name, a, say x or whatever. Let's say I'll call this a. So I have a is equal to 0.6666. So I have one digit recurring. So I will multiply this by 10 because I have one digit recurring. If it was 2 digits, I would multiply by 100. So I would have 10a. If I multiply 0.666 by 10, the decimal point moves one location forward. I'll have 6,666, whatever. Now, if I rewrite the original expression under this, this would be 0.666 forever. And if I take away this bottom one from the top, I'll have 10a minus a would be 9a. It will be equal to, and this will be 6.6666 forever minus just 0.6666 forever. So I'll be just left with 6. From here, a will be 6 over 9, and we should always simplify. They're both multiples of 3, and this would be 2 over 3. Now, the shorthand version of this is exactly similar. I'll just go through it so that it becomes clear. I will designate this to be a. Then I'll have 10a is equal to, this would become 6.6 dot. 6.6 dot is the equivalent of this 6.666 that we had on the right hand side here. Then I will write a as before under this. A is 0.6 with a dot. I will take away. I'll have 9a is equal to 6. And a is equal to 6 over 9, which is 2 over 3. Okay, now we look at another example. Here I have 0.242424 recurring. Now, we see that we have 2 digits recurring, so we can write this, as I said, we'll do this now in the shorthand. It will be 24 with a dot on top of each recurring digit. So I'm going to set this equal to a. Because I have 2 digits, I'm going to multiply it by 10 to the power 2, which is 100. So 100a will be 24.24 with the 2 dots on top. I rewrite the original underneath this. And if I take away, I get 99a is equal to 24. So a will be equal to 24 divided by 99. Now these numbers, they're both divisible by 3, so that becomes 8 divided by 33. So 0.24 recurring will can be written as a fraction as 8 over 33. Okay, here we have a slightly different question in that we have a decimal point which has only one digit recurring and two non-recurring digits. This number is actually 0.04666 forever. So the 6 keeps repeating, but the 04 does not. So how can we write this as a fraction? Okay, the way we approach these, we count the number of non-recurring digits. We have 2, and we have 1 recurring digit. So that makes 3. So first I will call this A, and I will multiply it by 10 to the power 3, because I have 1 recurring and 2 non-recurring. So that makes me 1000 A is equal to, and that becomes 46.6 dot. Because if I multiply this number here, 0.04666 whatever, by 1000, the decimal point moves 3 points. So I get 46.666, which becomes 46.6 dot. Then I look and see how many non-recurring digits I have. Here I have 2. So I'll now multiply that top equation by 100. So I get 100 A is equal to 0.4. Actually, the 0 need not be written. So it just becomes 4.6 with a dot on top. Now, as before, we do a takeaway. So I have 1000 minus 100, which becomes 900A, is equal to 46.6 dot minus 4.6 dot becomes 42. So A will be equal to 42 divided by 900. And this will simplify to 7 over 150, because 42 is 6 times 7, so it's divisible by 6, and 900 is divisible by 6, and that makes me 150. So 0.046 with a dot on top can be written as a fraction at 7 over 150. Now, just to give you all a very good grounding, I have here started a monster of an example. Now, you are not likely to get this in your GCSE exams, but it's a good exercise to go through so that you demonstrate your full understanding of this topic. So this is 34612 recurring. So if I call this A, how am I going to write this as a fraction? Okay, I have 2 non-recurring digits and 3 recurring digits. So initially I will multiply them both by 10 to the power 5. So that's 100,000. So I have 100,000 A is equal to, decimal point moves 5 points. So I'll get 3, 4, 6, 1, 2, and then decimal point, and then the 612 will be the recurring bit. Now I look at how many non-recurring digits I have. I have 2, which is 3 and 4. So I'll multiply this by 100, get 100A, which is equal to 34.612 recurring. Now, if I subtract one from the other, I'll get here 99900A, and this will be equal to 34578. So I'm basically taking 34.612 dot away from the top one, and that should give me 34,578, and the decimal points cancel. So from here, A will be equal to 34,578, that's a mouthful, divided by 99,900. Now this must be simplified, and I have taken the liberty to do this in advance, and the number that we get is 1921 over 5550. So this recurring decimal 0 point, let's put, I forgot the decimal here, 0.34612 recurring becomes 1921 divided by 5550. Well, I hope you found this video useful. Please click the subscribe button and give this a like, and I will see you in the next video.